All right, welcome everyone. At this point, you should have turned in your linear versus exponential assignment. What we're going to show you in this video is from that hypothetical table I did in Tuesday's video. We're going to show you how you should have answered each of the questions. Now, for experiment one. Now, my answers aren't going to match your answers because your table should have been different, but the process should have been the same. And the purpose for this is in experiment two, which you will need to turn in by the end of the class period today, is going to be graded for correctness. So we want to make sure you have the process down for that so that you're in good shape when you go to do those. So in Tuesday's video, we had showed you how to find the equation by doing your successive ratios, y2 divided by the one before it, and then take the average of those. And we got 1.46. Now, I just want to talk about that 1.46, and let's talk about what theoretically that would have been. Well, we ended up adding M&Ms there. So we would want to think, when you flip an M&M, what's the percent chance that the M came up? Well, it was a 50% chance because there's one of the two sides has an M. So 100% plus 50% gives you 150%. So theoretically, we should be somewhat close to 1.5. So hopefully when you did yours, you're somewhere in the neighborhood there. If you're getting like 1.3 or something like that, there's a good chance you might have made an error somewhere along the way. So we're going to go through each of these follow-up questions. We already found our equation. We told what the variables are. So for our other things, the 3 is the initial value. And the 1.46, that's our successive ratio. So in experiment 2, you'll do a similar type thing, so you'll make sure to include those. What would be a reasonable domain and range? Well, it's going to be dependent on your chart, but for my domain, my trials went from 0 to 5, so that's my domain, and my range, my M&Ms, went from 3 to 20. Okay, so your numbers will be different, but you'd have a similar idea. Now, keep in mind, your inequality sign should always be opening towards the largest thing. So be careful when you're writing your range, especially for experiment 2, where things were decreasing. Make sure your inequalities open towards the largest thing. So that was question 3. 4, we wanted to estimate our rate of change at the 8th trial. So we want to come up with our points. Our points are 8 and 8.01. And we've got to find the y values that go with that. So all I'm going to do is I'm going to sub those in to my equation. When I sub in 8, I get 61.936 ... and I got 62.170 ... Now, you likely have an 8 value in your table. Use your equation, though, for consistency. Because your equation, it's a model that roughly represents your table. It's not going to be exact. We want to be consistent when we're doing our slope. So if you use the table value in trial 1, that's okay. But make sure when you do experiment 2, use your equation to get both of those y values. So now I'm going to do change in y over change in x. And when I do that, I get 23.48. Just keep it out to a couple spots. A rates unit should be something per something. It's the y units over the x units. So we should have M&Ms per trial. And it makes sense that we got a positive rate because this one was showing exponential growth. So that was 4. 5, predicted the number of M&Ms at trial 15, and then 6 at trial 20. So for this one, I would have y equals 3 times 1.46 to the 15. And when I do that, to the nearest M&M, I get 876 M&Ms. Can't have a partial number of M&Ms, so just round it to the nearest whole. And then we wanted to do the same thing, but for 20. And for that, the nearest M&M, I got 5,810 M&Ms. So that's if we were to keep going on. That would have been a lot of bags of M&Ms and a lot of counting. So we didn't go that far. And our last one for this, number 7, how many trials would be needed to have 300 M&Ms? Well, M&M's is a y, so we'll have 300 equals 3 times 1.46 to the x. First thing we would do is divide by 3. And then because we want to find an x that's in an exponent, we should be using a log. Base of the exponent same as base of the log, so we'll have base 1.46 of 100 equals x. And when we get that, x is equal to 12.1. So because this was increasing, that means at 12 it wasn't there yet. So the 13th trial is the first time we'll have at least, how many do we have? At least 300 M&Ms. Okay, because we only had whole number trials. So if we look over at experiment 2 now, we had already numbered everything from Tuesday's video, all of the questions. So by the end of the period, you need to have turned in your answers, including your graph to this. You'll upload it right on Schoology. It's going to be graded for correctness out of 5 points. So just the one thing I wanted to remind you is when you did your table for this, maybe this was like 7, 3, 8, 1, and then 9, 0. So you go through, you do all your successive ratios. Remember we said because normally an exponential function wouldn't go to 0, just don't do that last successive ratio. Just do the other successive ratios and average them, and that'll give you an equation that's a better fit to your data. Okay, so exclude that last successive ratio. Remember you're doing the successive ratios, y divided by the y before it, and then do the average of those to find your b value. So hopefully most of you had already at least started question or experiment 2, but if not, you should have plenty of time this period to go through and finish that. So again, that has to be turned in by the end of the period. Once you finish experiment 2, you're going to go on to experiment 3. So in experiment 3, first thing I want you to do is you can cross out, and this, by the way, is on page 2. You can cross out, create a hypothetical data table, and draw a graph. We're only going to write an equation for this. And same thing down on the bottom. You can cross out, create a hypothetical data table, and draw a graph. We're just going to have you create an equation. So you need to think about a hypothetical 4-sided M&M. Well, remember in experiment 1, we said hypothetically an M&M should be added 50% of the time. So we had y equals our a value, and hypothetically it would have been 1.50 because we were going up by 50% each time. And in experiment 2, there was a 50% chance we took the M&M away. So 100% minus 50% gives us 50%. Okay, so notice for this one, so we'd have whatever our a value was, and we'd have 0.50 to the x. That's what we would have had theoretically in experiment 2. So you need to figure out theoretically what would we have if there's a 4-sided M&M, an m on one side, and we're adding each time. So you should be able to come up with an equation. Now for this one, just so everyone's doing the same thing, your a value, remember we started with 3 M&Ms there. And it says to use your number of M&Ms from experiment 2, but just so everyone's doing the same, let's have everyone start with 100 M&Ms for a value down in experiment 3, number 2. So these ones should be pretty quick because all you got to do is you got to come up with the equation, and then it just asks you to practice a rate of change in each of them because that's something we'll continue to see in this unit. So you'll have one practice for each of those. So that you just have to complete it. You don't have to upload the experiment 3. So your task for today is to finish experiment 2, take pictures, upload that on Schoology, and then do experiment 3. Whatever you don't finish out of that would be your homework for tonight. But you should be able to be done with experiment 2 by the end of class today. Okay, that's designed to be uploaded by the end of class. If you don't finish experiment 3 in class, you can do that for homework tonight, and we'll talk about that the next class.